Okay, welcome back everybody from lunch. Hopefully you had something yummy to eat. Um, we are about to go live with the next presentation. Spark 3 is here to unify big data, and that is going to be brought to you by Jean-Georges Perrin, and or JGP as he's otherwise known, is an enterprise architect focusing on innovation and advanced auto parts, and the author of Spark in Action. He is passionate about software engineering and all things data, big and small, and his latest endeavors bring to more and more data engineering, data governance, and his favorite theme, the industrialization of data science. He's proud to have been the first in France to be recognized as an IBM champion and to have been awarded the honor for his 12th consecutive year. Jean-Georges shares his more than 25 years of experience in the IT industry as a presenter and participant at conferences and through publishing articles in print and online media. His blog is visible at jgp.ai, and when he's not immersed in IT, he loves enjoy exploring his adopted region of North Carolina with his wife and kids. So let me send his video live, and welcome to CodeCamp.
Hey, thank you so much, Stan. So, I'm really excited to be here from my very distant North Carolina. One of the issue of being from North Carolina to you is that it takes about 20 seconds from my voice to reach your ears. That's a lag we have, and so I cannot make that more interactive than that. So you will have to hold your questions for the end, and I'll try to make that as fun as possible afterwards. Um, so thank you for being here on a Saturday afternoon. If you, like me, are spending all your days on Zoom, I really appreciate for you to come here. So let's get started. Yeah, as Stan stated, my name is Jean-Georges Perrin. I often go by JGP. I started software like in 1983 and started making money out of it in 95. And I've been since, doing big data, more and more AI. I'm an IBM champion. I've been doing that for 12 years. It's one of my pride. And we recently created La French Tech. So yeah, this accent you're feeling is a French accent. And La French Tech is a hub of participated people in the Raleigh-Durham area. You can reach me at Twitter at JGPerrin, and my blog is jgp.ai. Yeah, and I work at Advanced Auto Parts, which is a great company. We are doing a lot of fun things in the digital space. I'm an enterprise architect there, having a lot of fun. I wrote this, yeah, and that's where the advertisement stopped. I wrote Spark in Action, the second edition, which has been published in June, so it's pretty recent. Covers Spark 3.0 with a lot of examples in Java, Python, and Scala. It's got 4.8 stars on Amazon, so I think people are kind of enjoying it. So, but let's dive in. What's big data? Big data is defined by many people like 3V, 4Vs, or 5Vs. And basically, it's the idea of volume because there's a lot of data, variety because there's a different kind of data, velocity because it comes faster towards you, and variability because it's different source, different nature of the data and values. So that's the I would say traditional corporate almost definition of big data. One definition I like better is data is considered big when it needs more than one computer to be processed or stored, and I think that's really a more an easier way to do it, and it doesn't apply to one technology. You can have big data when you've got clusters of relational databases. That works too. Okay, we don't have to do that. But today we are going to speak about Apache Spark. And Apache Spark is, I like to define that as an analytics operating system. I got the sentence. I got this definition from a friend of mine here on the left on the screen, Rob Thomas, which now is a SVP of Cloud and AI at IBM. But what Rob was telling is that Spark is not a framework or a tool; it's just really an operating system. So that triggered me, and even if I knew Spark at that time already, I wanted to listen to try to understand a little bit better what was really going on. So why is it an operating system? Or why is it an analytics operating system? When you develop applications, usually you will rely on the hardware. On top of your hardware, you've got your operating system, which create this abstraction for your apps, and then you can build your application, right? That's Windows, Linux, whatever. That's how they work. When it starts to be distributed, you have the hardware layer, you've got the operating system layer, and on top of that, you will have to develop your apps, right? Logical. But when you're doing that, you will have to add the distribution layer, the distributed layer, and the analytics layer in your app as well. So basically, it removes a lot of the benefit of having an operating system. So you just keep adding stuff to your app, and you're creating a big, fat, lazy, ugly app, which is not what any of us want to do, right? So let's look at a different paradigm where you've got the hardware, your operating system layer, and then you've got two layers, which is your distributed operating system and the analytics operating system. And on top of that, you build your application. So that is Apache Spark. This analytics and distributed operating system, that's where Spark can help you. And moreover, you can use different languages like Python, Scala, R, and Java. So you're going to ask me who's going to use Spark and what kind of usage we can expect from Spark, really. And that comes to understanding a little bit better who the data engineers and the data scientists. So really, a data engineer is building, testing, operationalizing data so that it can be exploited. Okay, it takes the data from somewhere, make it available, create data lakes. Eventually, if you're into this kind of stuff, or as we see later, lake houses. It's going to develop processes for data modeling, pipelining, etc. Okay, so that's a data engineer. The data scientist is, I almost like to call the data scientist a guy who also girl, who whispers at the ear of the data. You know, it cleans it, it massages it, it organizes it. It's going to perform analytics. It's going to look and prepare, build data predictive models, and it's going to try to find the hidden gems you have in your data. And really, it is a storyteller. It takes the data and build stories for your stakeholders in your company. So what tools are those people using? So you can see that the data engineer is using traditional tools you would expect, relational database like, I don't know, Informix, IBM, Oracle, IBM and DB2, or even Informix actually, PostgreSQL, Hadoop, some stuff on the AWS stack, Elasticsearch, etc. You're probably all familiar with all these tools there. On the data scientist tool side, you will find people using IBM Watson Studio, for example, Databricks, SAS, MATLAB, Tableau, and even, or of course, Jupyter and Zeppelin, which are super popular in the data science world, but also tools like Excel and PowerPoint, because they are part of your storytelling, right? But in the middle, there's a set of tools which both the data engineer and the data scientist are going to use. And this is really Spark, SQL, Scala, Python, and I'd like it more, personal preference, Java. But I know that it's the data scientists are not using that a lot, but they're using a lot of Python. And Python and Java goes well together. So let's drill down a little bit more into Spark, and specifically Spark 3. So Spark is 10 years old, believe it or not, and it's been a growing and very maturing project. And this year we were all very excited to see this version 3 coming out. And clearly, one of the usage of Spark is using notebooks, and that's specifically when I was talking about this Jupyter and Zeppelin. And this is what a lot of data scientists are using. And they are majority using Python, and you can see a lot of SQL as well in there. And that's the source of that is one of the founder of Spark, Matei Zaharia, who also has I think he's the CTO of Databricks, the big company behind Apache Spark. So see that Python is really more and more being used there. A few more figures just to understand a little bit. Databricks offers a platform. In this platform, they are processing more than 5 trillion records per day with structured streaming, which was introduced not that long ago in Spark version 2, and now unstabilized in Spark version 2.2. And 90% of the APIs are SQL based. So I'm not going to go too much into the internals of Spark, but a lot of the code is actually transformed into these APIs, whether it's SQL, Java, Scala, Python, or the data frame API, and that's a lot of the APIs that are just relying on that on Spark SQL. And so a very interesting thing as well, comparing the last production version of Spark, which was version 2.4, to the newly released production version versus Spark 3, that it's also much faster. Okay, and that's using the TPC data science 30 terabyte benchmark. So I'd like to focus a little bit. You may have heard, and unfortunately, we cannot really, have this kind of exchange that we all would love to have regarding Spark and your experience with Spark. But I wanted to focus a little bit more on what's new in Spark version 3. It has an overwhelming 3,400 Jira tickets that has been processed. And you can see that when you compare it to the other graph I showed you, that Spark SQL was really a big target for optimization and new features, as well as, of course, the core of Spark, and we're going to talk a little bit about that, and as well as, of course, PySpark and documentation as well, and we talked a bit about that. So here is my kind of nutshell, highlights in a nutshell. So now, when we're talking Python, Spark 3 is only going to be Python v3, okay? Bye-bye Python v2. There's a better error handling for Python. Basically, you don't see all the Java stacks that was there. And koalas are, so I need to define what koalas are, but the support for koalas is much better. Koalas is basically the same implementation as pandas. Pandas is a library, is a Python library that a lot of data scientists are using, but basically the community has been working on koalas, which are taking the same API as the pandas, but making it run, instead of natively on the machine, making it run potentially on a Spark cluster. So you don't see anything, you don't change your code that much, and it runs on a cluster. SQL, better, ANSI SQL. I mean, that's I'm not a big fan of believing in ANSI SQL, but it makes adoption a little bit better, and I think that's useful in that direction. At the core level, it's adaptive query execution, and we're going to speak a little bit about that, and the support for Java 11 was finally, and Scala v12. So you may or may not know, Apache Spark is written in Scala. They've decided now to standardize on Scala v2.12, which is a great thing, I think, and remove support for 2.11. And that also allowed to have support for Java 11. One of the key features, which it's one of my favorites, is a subsystem called Hydrogen. And Hydrogen is basically telling the scheduler more information about the hardware, so it can dispatch the tasks according to your preference or to the need in a better way. So let's drill down in a few of those to understand a little bit better. So first, the optimizer. The optimizer has always been there. It's called Catalyst. In version 1, it was a rule-based optimizer, and in version 2, they introduced a cost. So basically, IBM contributed the optimizer cost from other products they had to Spark. And in version 3, Databricks and Intel have built this runtime adaptive query execution. Okay, so sorry. So that's the idea there is to dynamically do a few operations, which is basically shuffling partition. So basically, as you can imagine, like any, it's not a database, but like any data storage, you could create partitions for your data. Sometimes it's created automatically, and that's impacting specifically some operations like joins, and so it's going to create some bad situation where you've got data skews where you're joining between two partitions on different nodes, and that's going to create a lot of traffic and a lot of problems. So in terms of performance, so the problem with that was that it's not completely easy to debug. So adding this level of automation within Spark is a great benefit now. You can still do it manually if you feel like you're better than the machine, which that can happen. But having this AQE is a good benefit. You will not see that. You will not see the issue. I was trying to mimic that on my Mac here, but you don't see much. You've got to create really big. It's really when you manipulate big data on more than one computer that you will see the benefits of that. And really the big complex thing is to actually disable it. By default, it's enabled, and you see it there in your config. When you create a session, you specify whether you want it or not. And yeah, I think it's enabled by default. So and there's also, if you're familiar with Spark, there are static functions, and static functions are a really important part of the data transformation you can process. The community has added something like 36 new functions, and they're all documented in a free companion book you can get from the Manning website there. You just download it, it's all documents there. SQL, for some reason, I always think of SQL as a soup, and that's probably a personal bias. I don't know. But finally, we've got a reference guide for SQL for Spark, and you've got the URL here at jgp.ai/sparksql. It's actually a shortcut, a short link to the latest version of this document. If you're familiar with Spark, one of the great things is explain, which is explaining the query and the optimization your query is going through it. It can be formatted so you don't break your eyes when you actually read it. The support for Dates and calendar is a bit better as it's supported based on Java 8 and not some like cumbersome things they used to do. Doesn't change that much, only if you're probably dealing with dates which are before 1582. There's an overflow check as well, which is really useful when you're manipulating and converting ints to longs, and this kind of shady things that may happen in your application. And you can also, as I said, play a little bit with the NC configuration, NC compatibility, but that's a configuration flag as well. So one of the other features I kind of like is push down in the ingestion. So the ingestion is a really, really important part of any Spark application, where you basically get the data there. It was already available in databases, and now you can filter. You can filter also with CSV. The benefit of that is that instead of bringing all the data in your app and in your memory, and you're kind of removing the data after it's in your memory, it's just going to take it. It's just going to filter it out. Okay, so that's something that was already there, as I said, in SQL. So you could import from it's not a well-known feature, that's why I like to put it there as well. If you've got your SQL query, and then when you're ingesting your JDBC, you can use the syntax here, where you see that the SQL query is aliased, and you will only see the result of that. So you can, here I did a join, but you could do you could do a filter of any kind, or limits to avoid traffic going to your data frame, which is a storage unit in Spark. So here is an example of how you do it with CSVs. As you can see in the code, here is a very traditional code for ingesting CSV data. I'm loading a file, I'm combining a filter where I only want the author ID with 1, and then I'm going to see only those books in my data frame in memory in Spark. And that's this example can be also downloaded. All that is on GitHub, on my repo, and this indicates that it's actually chapter 7 and it's lab 201. So you'll easily find that. So another thing is migration, because you will have to migrate. It's not a completely straightforward operations from Spark 2.4 to 3. It's not a rocket science operation as well. Okay, so in my case, using Java, the compiler will detect quite a few exceptions that have been added, specifically in structured streaming, and then there is a bit of a runtime issues. Two things to note is dates. The date parsing has changed, so that has a little bit of a consequence, and the data sources has changed a little bit. The way data was ingested in Spark has been through data sources. Up to now, it was considered the data source v1 API, and Spark 3 introduces partially data source v2. It's on the way, so you may see a little bit of a difference there. So just to make sure you're aware of that when you're ingesting your data. My main issue was this one. As I was upgrading, I had some dates, and the only thing I had to do was really to either set a property after you've got your session, or when as you were creating your Spark session. Okay, so that's not that difficult. Okay, and there's two values. There's legacy, and I'm of course spacing out the other one, but legacy is if you want to keep correct to the legacy. if you want to keep your applications the way they were behaving, you just keep legacy, or you force it to correct it if you want to use a new behavior. Okay, so a lot of theory so far. We've seen Apache Spark as an analytics operating system. We've seen some of the new features in Spark v3. If we had to go through all the features in Spark v3, it would take days. Yeah, at the pace of, let's say, 2 minutes per feature, it will take a lot of time. So now we can look a little bit into an example, and I picked an example which is close to us, which is about ingesting and putting some data quality rules in place for COVID-19. And I felt that it was really safer to actually use Java for your own sake. So that's why we're using Java. It's not because it's my personal preference; it's just for your personal safety. So let's look at our use case. We are going to get some data from the Johns Hopkins University, and we're not going to predict, but we're going to prepare all the data so that it's ready for us to be used in a predictive model, for example, or in other aggregation, but doing all the part that is going to be done. I'm going to give a talk specifically on the rule process this Tuesday on Twitch with Manning, but I just wanted to focus this today, given time, on the ingestion part. Okay, so what I like to describe is the process, the data process you're going to do, or the data pipeline. You call it all you want. We're going to take some data, and this data, yeah, we're going to take some data, and we're going to ingest it. Once we have ingested this data, some people call that also the landing zone, or the bronze data, or even swamp. There's a various set of names, but I like to call that raw data. Okay, you ingest the data from the different systems or files, and it's in your system, and I consider that raw data. It's raw because it still needs to be processed a little bit to apply some data quality rules, to make sure that you get some data which you can exploit after that. So here, in this situation, I'm going to apply a very few of some data quality rules, and we are going to have what I call pure data, but you also see that as refined data, as a refinery zone, silver zone, pond, sandbox, or exploration zone. I just like it pure because it's some things that you can actually exploit at that time, and you can transform. So after the pure data, we're going to transform it to, and the result of this process is rich data. This is not what we're going to do today. And after that, you can publish it, and you've got actionable data. Okay, so this is a typical pipeline of operations you're doing in a big data project, and Spark is there for doing all that very nicely and very swiftly. So the first operation is really about collecting the data. Okay, so we're going to collect the data from GitHub. Johns Hopkins, as a leading school of engineering, is actually providing all this data for us on GitHub, and I should have written the URL a little bit better, I guess, but you can also find it in the code, of course. But it's github.com/GSSEGI send data. Okay, and to do that, we are going to automate the process as part of our pipeline. When you get your data, one of the first operations you're doing is exploring the data, right? Because that was when I started this project, I wanted to have a certain kind of data, and this is the data I found. Okay, so in January, for example, I only had 5 columns. Okay, as you can see, mainly from China. as many things are coming from China these days. Even the data is coming from China, but it was actually here the collected data. So if you look closely at what was happening, at what you see here, you see things like the province/state, the country/region, and that was really the headers of the CSV files. It's actually still the header of the CSV files. You see the date, which is kind of a weird American/military time, a mix there, and the number of confirmed cases, the death and recovered cases. Okay, when you look at the data for April, you've got the FIPS. So the FIPS is really the first two digit is the number defining the state, and then the county in the state, and then you've got an admin 2 column, which is basically the name of the county in the state, and then you've got the province _ state, which used to be province/state, country region _ region, which used to be country/region, and you see here that the last update is different. The years are on 2 digits, and they used to be on 4 digits before. They added things like lat and long underscore, etc., etc. So I had to build a system that would be able to be flexible enough to ingest all this data. And then finally, my next operation was kind of organize the data. As I said, some of the dates are in ISO, sometimes US, sometimes some kind of a mix. When you look more precisely at the data, you also see that China is sometimes written China or main China, actually mainland China, sorry. And South Korea has kind of 3 variants of writing. There is absolutely no unique ID for location in the early version, so if you want to make some aggregations, there's no way you can do it. Files are, of course, in different encodings, otherwise it's not fun. And basically, at this point, it's about 400 lines of Java code that I use to do that. I run a vlog called Data Friday, and it's actually episode 11, where I go through the detail of this code, but we're going to have a look at a bit of that as well. So let's drill into the code. Here you can see how I'm actually starting my my app. So the first operation is a very traditional way of handling stuff with Spark, is really creating a session, and then you're creating you're giving some configuration parameters, as I just told you about the time parser policies that I'm using Spark 3 here, so I'm just changing it to corrected. The next line, master, is interesting because that's where it starts. Where do you want to start your master? So they still have the master. It's more like master worker now terminology, but still a master is to run somewhere, and it can be running globally, or it can be running on a cluster. If you don't know much about Spark and you know a few things about Hadoop, so Hadoop has a lot of components to it, and it's really difficult to run just Hadoop on a machine. If you've got a single machine, people run a big or set of VMs, and it's not always easy. Where Spark, you can run it locally, it works just great. I love it to run it on my Mac or on my Linux laptop, and it's just working very, very nicely. So you get a session, and from this session you can do things. So the first thing is I'm going to do is ingest the data and then apply the data quality rules, right? As in the process I've done. First thing is ingest the data. I've done a class, and we're going to look at that, called COVID ingester, that is going to deal with these operations. And then you can also see from there the storage mechanism, which is the data frame, or as in Java it's written as a data set of rows, which is really the storage and APIs we're going to use. So if we could drill down a little bit, that's my ingestion. I hope you can see it. Unfortunately, yeah, I can actually start showing you a few things here. I know the font is a little bit small. I try to make it bigger. I still have to work on that. But basically, what you can see is that the first part is syncing the repository. So I'm taking the repo, I'm taking it locally. Then I'm making a list of files here, a very simple list of files, all my CSVs. Then I'm reading the header. What I've noticed is that every file has potentially a different header. So, but these files are, and then I'm going to process them by the header. And that's what you can see here, this line where I'm calling this main ingest function using the path and the header and the name of the file, and then the file name. And then I'm going to just, what is interesting in terms of Spark here is the first one is going to be my intermediate DF that I'm going to load, but after that, all of them are going to be unions. So I'm just taking my data frame and I'm unioning them like you would union two data set into a SQL statement. Okay, same thing, same idea. When I look at my main ingest, that's where you see a switch on the header. And I'm just putting here only one, which is a case, this case of the province/state. That's the first case you find in the data. I'm calling that a very thoughtful name, ingester1 method. And I'm going to, well, actually, I'm also going to add a column here called ingester, and that is the value of 1. So I know which rows and which records are coming through which ingester. I could have done it here or directly in the ingester. Then I'm going, and that's it's not a theory example, and that's a okay, shameless link to my shameless plug to my book. I never tried to use easy examples, okay, like a data set with value ABC and column 1, 2, 3. Okay, that's not the idea. Here you've got a real scenario that you could be facing in your company. Okay, so that's why I'm not letting any chance. I'm creating the schema. It's not a complex operation, but it allows you to fine-grain things like every column name. And then you've got my data frame again, which I'm going to read. You see that it's CSV. I'm specifying the schema. I'm saying to Spark, hey, it has a header. And as every ingester has this kind of weird date-time format, I'm specifying it as well here. And then I'm loading the path. Okay. And then after that, I'm adding the missing columns. Okay, so here there's a column FIPS that I found in the latest generation of the data, but not in the first generation of the data. So I'm just going to create it. Same thing with a column called admin. You saw it before. Admin, and I'm going to do the same thing with latitude and longitude. Okay, so just to make sure that at the end of the ingestion, at that point, each ingester is going to give me a data frame which has exactly the same columns from one to another. Okay. So at the end of this operation, I'm going through all these files as one file per day. So it starts to be a few files from the first one was in January. Can't remember which day exactly, but it starts to be a few files and these different rules. But there, after that, I'm still not having data quality, right? This is where I have my raw data. It's ingestion. It's ingested. It's in the system. But my data quality rules saying like, hey, you must have only one South Korea, or you must have only one way of writing China. This is not in yet. Okay, so this is where I'm applying the data quality rules. Still in Spark. So this is this is how I do it. Uh, yeah, I know with Java and all these parentheses, you almost think that you're in Lisp, but no, you're not. If you're using Scala, the syntax is going to be the same, but there's going to be less parentheses. But anyway, works great with Java anyway. So first thing is I'm going to repartition everything to one partition, so I can actually have a, what I told about partition, just to make sure that everything is on one thing. And still, it's not big data. It's a lot of data, but it's not big data. And then the first rule I'm going to apply on country is if I've got Republic of Korea, then I'm going to unify that as South Korea. Okay. So syntax is a little bit weird. It's like a switch case, but you've got a. So I'm creating a column here with column country. Then when if you're a SQL guru, you could type that in SQL as well. Okay, I'm more a Java guy than a SQL guy, but you could do the same exact code in SQL. So when my column country is equal to Republic of Korea, or if the same column equal to Korea, comma South, then I'm going to have the value called South Korea. If not, then I'm going to leave the column as the same country, okay? And you can say the similar thing with China here, with the column country. When country equals contains China, then it's going to be use China. Okay. And then I'm going to create this combined unique key for each record, which is, I think, which is, but it's actually pretty wrong actually to call it a unique key, but it's a combined key which is composed of the state and the country. That's how it's just for aggregation purposes really. And then at the end I'm calling a date, and I'm going to make sure that the date is the last update date of which I find, which in this scenario also converts it to a date just in case it was not a date. So that's the data quality rules. You can have more. This is very simple. It's basically three rules: one for Korea, one for China. Creation of the combined key, so we have it everywhere, and actually a nice date column as well. So nothing rocket science here. And then you've got, at this point, you really have your data, and at that point where you can start having your analytics. Okay, you could save this file as Spark or whatever, or store it in another database, and then or locally, or just start from there doing your analytics. So and get to the next step. So it's really, and you've probably seen this graph. So if you want to start machine learning at this point, or AI, as marketers will sell it, it's the same thing as ever. It's the same old adage: garbage in, garbage out. So at least here I showed you to have not that much garbage going on. So, but going back to our idea of Spark 3, I gotta, I'm kind of teach you one word of French, one French expression, which is mi fig mi raisin, which means I'm a kind of either fig or grape, which is really nothing about wine. It's really about having a mixed bag of films. It's a great new release. We made a major step, but it's not a. I've been doing Spark for a long time. The difference, going from version 1 to version 2 was almost a cultural shock, whereas version 3 is a very, very nice evolution, but not a revolution. But we don't always want revolution, right? But the thing is, one thing I really, really like about what's going on with where it's going is the idea of a lake house. So if you ever read my book, there's a section in the appendix, because my editor didn't want me to put that in the main part of the book, where I'm kind of ranting about a few things and the evolution of data. And one of the things I've been a relational database guy for a long time. You can see that I'm not completely young, and I looked at data warehousing, I looked at data lakes, and nothing is really satisfying. Okay, data warehousing is a pain to set up. Data lakes are not a pain to set up, but they often turn out to be a big swamp of data. The idea here is to have an operating mechanism called the lakehouse, which is avoiding these issues. And the big push behind that is the company that is also behind Spark, which is Databricks. In this schema, you can see a few of these components. Okay, so if I start by south here, you will see that I've got my all the data stream, all the data I can ingest, data sources I can ingest. So it could be other database files, different systems, streams. All that goes really nicely into Spark. And on Spark, you can apply rules like ML flow, which is really about machine learning, and some of the data quality rules I showed you, and something I'm working on, and hopefully I can talk about it soon to more public, which is this TBA box there. And at some point, you want to be able to, you're happy with your data. You've transformed it in such a way that it's satisfying for you. So what do you want to do? You want to save it to a file, to a CSV file, and having the same mess again, or you wanted to store it in a database, but that's an outside system which needs to be managed, etc. Or you could use something called data lake, which is a database which is really, really close to our system, and that's really our Delta Lake here. And what has Databricks introduced here is also the Delta engine, which is an engine sitting on top of Delta Lake, and that's going to be very interesting when you want people to be able to exploit your data more directly, almost like a traditional database. And then you've got a various. Of course, you're not going to process data for the sake of processing data. I know some people that do, so don't laugh. And you will see some exploitation of this data through data engineers once more. Okay, so you will see that when you look at the east side, you've got all the other database, the files, systems, and streams. Okay, which can be output from Spark. You will have the data scientists, which will probably use tools like Jupyter and Zeppelin that will be able to exploit data directly from Spark and leverage the cluster performance of Spark. Or you could see this new tool, open source, and even if it's open source, it's been bought by Databricks, called Redash, which is a dashboard for business users. Okay, so yeah, you may need to know a few things like SQL to do a few things, but you don't need to learn Python, Scala, or whatever to use it in Jupyter. So that's where I'm really optimistic about the unification of big data, and this is really where Spark is going to be one of these key components of this lakehouse system. It's really an ecosystem. It's really a unity around the big data, and it's probably going to be. I'd like to see that replacing a lot of the data lakes we see failing right now. So it's almost time to end. So I'd like you to take a few takeaways from that. So that's kind of the only one slide you need to remember from all of that. Apache Spark is really, it's an analytics operating system. People would like to define it as a framework or whatever, but it's really something you will be able to build on. You can build very serious and very resilient and very powerful data pipelines that scale. Spark v3 is a major update. Okay, and with more than 3,400 patches and I say patches, but it's really, kind of Jira tickets. And it's creating now this foundation for this rich data ecosystem we're talking about. And one thing I like a lot is that Python is increasingly popular and it completely beats out Scala. And if you're curious about it, you can ask me the question about why. But and then finally, I would say that it's this cornerstone for this lakehouse concept that that we are experiencing or kind of visualizing. So I'm finishing. You can start to think about your questions. Don't remember that it's like we are on the moon. It takes about 20 seconds for an interaction. So feel free to shoot any questions. I'm really happy to answer any of them if I can. And I would be, if I can't, I'm happy to do the research for you. So thank you very much. You can join me on Data Fridays. It's kind of this vlog I'm doing. You can see it on jdp.ai/Data Friday. I meet with people, I do experiments with data, put that on YouTube. If you look on YouTube for Data Friday, you will find quite a few videos there. And yeah, thank you very much. And please shoot the questions.
So thank you very much. We don't have any questions currently. So like you said, it may take a couple seconds for people to catch up. Well, you must have answered everybody's questions so completely.
Okay, great. So anyway, guys, thank you very much. Oh, sorry.
Yep, that's fine. We will take a couple minutes break. We are coming up at what time is it? At 2 o'clock.
Yeah.
We will have Dan Hermes doing some machine learning with Xamarin Forms. And I have tried to get the music working, and I have not been able to. So unlike the Etsy channel or etc. channel, we do not have music in between. But we will be back shortly. And thank you again to Jean-Georges. And talk to you in 8 minutes.
Thanks, guys. Bye-bye.